So I'm going to go ahead and there we go. Cool. We are now live on Twitch as well. So hello, everyone. Welcome to the workshop on Docker. We're going to talk a little bit about what Docker is and basically how to use it to do really cool things. I'm going to go ahead and share my screen. And I will share this. Window, there's a way to do full screen. Here we go. Full screen. Cool. Great. Okay, so we're going to talk about what Docker is. We're going to talk about how to write what's called a Docker file, which sort of defines what our Docker container looks like. And then we are going to, basically figure out how to get our app on the web using this Docker thing. So what is the problem that Docker solves for us? Why do companies use this thing called Docker? And not just companies, but like people too. There's all sorts of things you can get on Docker. I run Docker containers at home. The reason is because of this thing that we call dependency help. Basically, like all software needs certain things. So if I was to run an application that's using like Node.js, for example, which is a programming language, and maybe I need specifically version 14.1. Maybe I need this thing called FFmpeg, which is like this like video encoding sort of software. I don't really know what to call it. It does a bunch of things. But if you've ever streamed to Twitch using something like OBS, it probably uses FFmpeg underneath the hood. We might want to say something like we need port 80, which is when you go to an HTTP website, it basically, when it connects to that website, it says, give me whatever associated with this number 80. And that's by default, that's the default HTTP thing. So maybe the software says it needs that. There's lots of things that software needs, and you're probably familiar with this just with your day-to-day life, like when you install software and then it's like, oh, I need to install this other thing first, right? Docker allows us to get rid of this stuff. And we'll talk about how. So this is the old way that people would do things on servers. And if you're not familiar with the Mac style thing, basically all of these are folders. Just think of all of these as folders. And let's say that we wanted to run two web applications, two different websites or something like that. In this case, I have them using Python. And one of them is in this folder called app1, and one of them is in this folder called app2. They both have their own requirements. They both have their own application themselves. And then separately, somewhere else in our system, we've installed all these packages, right? So these things are going to require certain packages, and we've got them installed. This is the way that most people install things. If you install software on your computer today, that's how it works, right? You install Firefox, and it installs into the Firefox directory, but then it probably also needs Microsoft C++ redistributable. It doesn't matter what that is. It's just saying that a lot of software needs. And so that'll get installed somewhere else, right? You install a game, and it's installing the game, but it's also installing the Unity runtime or the Unreal Engine runtime. That's the way that your computer works. That's the way that people used to install software on the web as well. Now, there's a problem with this. Let's say that this application needs Python version 3, and this application needs Python version 3.1. Or what about if this application needs version 1.0 of a package, and this application needs version 2.0 of a package? Or maybe both of these applications need that FFmpeg thing I was talking about that helps with video transcoding, but one of them needs version 5, and one of them needs version 6. You can't install two things to the same directory at the same time, and basically it's going to be impossible to run both of these applications at the same time. And you may have seen this yourself if you've tried to install something on Windows or Mac or Linux or whatever, and then like some other application kind of breaks sometimes because like it updated some dependency that other application also needed. It's just like it's a really big problem to manage all these things. And it also takes a while to configure this all because oftentimes they don't automatically install or something's wrong with it or whatever else. So what Docker allows us to do is it allows us to basically give everyone an image of a working machine that they can just run directly. If you've ever seen something like a virtual machine, it's similar to that. So the idea is we have this thing called Docker, and each one of these two applications that we were talking about that have their own, they need different versions of Python, and they need different versions of these packages, and they need different versions of FFmpeg. They have different versions of things that they need. Rather than installing any of those onto your actual computer, the actual computer you have, rather than doing any of that, what you're going to do instead is have these two different Docker images. And in these Docker images, everything related to that application will be there, and we'll actually basically give things this Docker image. Now, if any of you have, let me make sure I have the chat open in case anyone is already asking this. It doesn't look like it. But if any of you have ever tried using virtual machines, or maybe like an emulator for, like a GameCube emulator or a PlayStation emulator or something like that, you're probably familiar with the idea that like it's not perfect, right? Like it's often slow. It takes up a lot of CPU on your computer to do that. And that's because you're emulating the entire, the entire CPU. Like it's just not very fast. But Docker actually does this in a really clever way. Even though all of these applications are completely separate, let me, I thought I had this slide in here. Do I not have this slide in here? Okay. Well, even though all these applications are completely separate, basically what happens with Docker is that instead of using a different a virtual machine, what's actually happening with Docker is that it's actually sharing the same operating system between all of the different containers, which is really, really neat. So basically, both of these containers, the one thing they definitely have in common is they're both on the same operating system. They both need to run on the same operating system. And in fact, Docker only really works properly on Linux. If you use Windows, you can still run Docker. What it's going to do is it's going to start up a single virtual machine, just one virtual machine, and all of your Docker containers will run inside of that. Because what's happening is that all of these are sharing the same operating system. It's just that every single file inside that operating system is going to be different, which sounds weird, I know, but trust me, it works and it's not very slow. It leads to almost no slowdown whatsoever. It really, when I was first learning about this, I didn't want to use it for a while because I was like, this is going to be really inefficient. It is not. It's almost imperceptible and it makes your life a lot easier. Okay, so the idea is that basically all of these requests go into Docker, the Docker program as well, and Docker will direct it to the required app, the app that's associated with that. And Docker will make sure that the apps that you want are running, and it'll stop apps when you want them to stop. So Docker takes care of all of this stuff for you. So for example, if I were to try to visit a website, what will happen is that Docker will give each one of these containers its own port. And so even though both of these might want port 80, if I go to, port 8001, it'll redirect it to port 80 in this container. Docker can also remap file folders. So this application might need all of its data to be stored in /my/folder, right? Some particular folder. This Docker program can actually remap that folder to be a real folder on your hard drive. So that the files actually get saved to your hard drive rather than this container, which is going to get erased whenever it shuts down. So Docker will take care of those folder things as well. Okay, so how do we set up one of these containers? Well, this is the other really cool thing about this. We actually code our container. We actually write code that defines what version of things we need and how to set up our application inside of a Docker container. So here's an example of what a Docker file looks like. From Python 3.8, we're basically saying we're going to load the sort of, a higher level Docker image, an image one level up. We're basically going to we want an operating system that's got Python 3.8 already installed. And I could actually change this to a different version of Python or something. I'm going to say run apt-get update, apt-get install ffmpeg dev. So this is going to basically run a command in part of that image building step. So it's going to put this into this image that can then be run on other people's computers. This is the building step, and we'll cover that again in a second. I'm going to copy a file called requirements. which is going to define what our Python program needs, what packages it needs. I'm going to tell the Docker thing that we're going to be working inside this app directory, which is where we copied our requirements.txt file. I'm going to run a command called pip install to install those requirements. I'm going to copy our entire application. And then I'm going to say, when we start this container, here's what I want Docker to do. So everything up from here to here is basically part of building that image. And this bottom part is saying, and when we start the image, this is what we do. It's like putting something in your startup folder on Windows. So what we do is we run a command called docker build, and it takes everything up until here. It runs those commands, and it creates what's called an image. And then whenever anyone in the world wants to use our image, we can use this Docker run thing to run that image. So we Docker build, it does all of this stuff, it produces an image. That image will always be the same. It should work on pretty much every computer out there that is capable of running Docker. Any computer in the world can run this image, and it'll run exactly the same, which is amazing. There's no more need to really define how to get this all set up. We just send them the image and it works. It's cool. It's so cool. And then they just Docker run and they get a running version of your application. Docker also has this built-in thing called Docker push, and it basically pushes this image up to the web. It's like GitHub, if you ever use GitHub. It's like GitHub just for Docker images. And so you can actually upload these Docker images to the web, and then anyone can download them. They just Docker pull to download the image and then Docker run, and they'll get that exact copy of the image. Cool. So that's it for the presentation part of this, but I wanted to show you some examples of what this looks like in the real world. Like, how do we use these Docker containers? Now, if we wanted to set this up for ourselves, I don't know how to, there we go. Cool. If we wanted to set this up for ourselves, how would we use this? Well, first of all, we download Docker. And there's a desktop version. You can just download it. It'll give you even some nice stuff, so you don't have to run your own command line. You can just click on things and run them. So if you want to run this at home, this is what you would do. But what if you want to get your application on the web? What if you want to use the web to set up your Docker images, right? Well, again, remember, any Docker image is going to run exactly the same on any computer. So what we would do is, first of all, we would test it on our local computer. We would write the Docker file. We would build the Docker file. We would run the Docker file. We would make sure it works. And as soon as it works properly, as soon as we know it works, we can send it to any computer and it'll work the same. So what are some examples of computers that we can send this to? Well, the one that most of you are going to want to use is something called Heroku. Heroku. It's a free service. There are some limitations, but it's free. It does not, at least last time I checked, does not require a credit card to sign up for it. You can only run so many applications at once and they'll shut down if no one uses them for a while. Heroku is a place where you can send Docker images and have them running, and you'll get a real website URL. And that website URL will go to your Docker container. It's very, very cool. I'm not going to be able to go into the specifics of how to set up a Heroku app today. And it's also going to be a tiny bit different for everyone's thing because you're going to have to set up those Docker files. But this is a thing that you can do, is use this Heroku platform. What I'd recommend doing if you want to do this, just search for Heroku Docker. And you'll see that they have a sort of step-by-step guide on how to do this. They even have local development and everything else. So very cool. Now, in the real world, what does this look like? Like for real companies that are wanting to do this? Well, let me show you an example of some Docker containers that you might have seen. Maybe you have been on the Discord and you've seen the John Peter robot. The John Peter robot is a Docker container. This is the Docker file we wrote. Let's see if I can make this a little bigger. This is the Docker file we wrote. You can see it's actually very similar to the example Docker file. To go to hub.docker.com. It's on Docker Hub. Let me just go ahead and log in really quickly. And then I think it's in code day, John Peter. This is our Docker image. It doesn't look like much, it's just a website, but here's our Docker images. And then we have our own sort of internal version of something like Heroku that's called Nomad. And this is all of our Docker containers. All of them are here. And if I go to John Peter Discord, you can see there's John Peter. He's currently running. He's doing all of the bot things that we want from Discord. I can even go in and I can see the logs from John Peter, of which, there's some weird errors. I don't know what this is about, but like the same thing you'd see on your computer, but this is running on a computer that we own. It's a Docker container. I can start and stop it super, super easily, right? You can see it just says running. We even have a tool for this, and Heroku has something like this as well called deploy. And I can actually go in here and I can find John Peter Discord. And I can see all of the different versions because the Docker image, just like any other code in GitHub, if you use GitHub, it'll actually save your entire history. It's like an undo. So I can actually undo to previous versions of John Peter. Same is true for example, Showcase. The Showcase bot that adds you to your pods with your mentors is also on here, right? The Showcase bot is running on Docker. I think there's probably more errors here. Yep. The Showcase website is running on Docker. If you go to showcase.codeday.org, this is actually running on Docker. We have like kind of an internal link that we can access here. Here's the Code Day Showcase page, the same one that you're familiar with. And if I were to go over here and find www showcase Docker container, here's all the changes we've made to that virtual showcase thing. Earlier today, even, I actually made a change to the main codeday.org website because some text was in the wrong place, and you can see it's deployed, it's running on Docker. I committed the code. We actually had a system that automatically made and pushed that Docker container, and now it's running on the website. So it's very, very cool, very powerful stuff that you can do with this. But when you go down and look at the code, and you look at the Docker file for Showcase, for example, 14 lines of code. Look at that. I mean, it's so cool. And it runs on my local computer very easily. Anyone who wants to help test something and make a change to the Showcase website can download this code, run the Docker file locally, test out their changes, push it up to the cloud, and it's just going to run exactly the same on the real server. So it's very, very cool. So I know I went through that a little bit quickly. Like with a lot of the workshops that I do, my goal was not that anyone would be able to do, every single thing about Docker at the end of this, but hopefully that's enough information that it kind of gave you the starting point to ask those questions in help desk. That's really what I want you to take away from this, is I want you to know enough that you can ask these questions in help desk. And even if that question is, how do I make a Docker file for my Python bot? Or how do I make a Docker file for my website? We can help you with that, right? We can help you figure out how to get started with that. But hopefully there's enough information for you to ask that question. So with that in mind, I have a few minutes here at the end of this. I'd love to take any questions you have either in the chat. You can use the Q&A feature, or if you're in Twitch chat, feel free to use that as well. Yeah, it's still open. I'll pull up one of these slides again just to make sure that this is clear what's going on. Any questions at all? It can be any question you want to ask me about Docker. We've been using this for so long. We have probably 55 different Docker containers powering Code Day. Someone wants to know how many people are watching on Zoom. 25 looks like. The Zooms have been up to, I think the most we had in a Zoom call was like 67. And the limit is actually 100, which is why we have the Twitch as well, just in case we hit that. Cool. Okay, I'm gonna head out so that the Robot Rumble people can use this. I hope some people will participate in Robot Rumble. It's a really fun competition, and you get to program some virtual robots to do things. I think they're also powered by Docker. Yeah, hope to see you there.